Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum. First of all, I would like to thank to my respected teacher who gave me opportunity to present my topic of presentation. It's me, Asma Ramzan, roll number 30, MSc Previous. My presentation topic is triterpenes, but we will over here discuss some basics about introduction, isoprene rules, classifications, definitions, types, uses, and at the end we will discuss some key points. What is terpenes and terpenoids? Terpenes are basically derived from a word terpene, which means a pine tree from which terpenes are obtained. It means terpenes can be derived from plants. Terpenes basically a precursor to all steroids, vitamin and cholesterol. Terpenes are simple hydrocarbons, contain carbon atoms in multiple of 5 made by joining together 5 carbon isoprene units are called terpenes. Terpenoids. Terpenoids are modified class of terpenes with different functional group at various positions are called terpenoids. Why we use the words terpenes and terpenoids? Why we use these two words separately? Terpenes, which shows a suffix "-ines", indicates that there must be unsaturation, means double bond. And terpenoids, which is a modified form of terpenes having a functional group at various positions. This functional group may be aldehyde, ketone, and alcohols. That's why we can't use the word terpene for the group having different functional groups, because the "-ene", which is at the end of the terpene, indicates the unsaturated hydrocarbons, not for the functional group. The diagrammatic difference between terpenes and terpenoids can be seen. In the terpenes, there is a double and single bonds, but in the terpenoids, the OH group, alcohol group attached to a molecule. Terpenes and terpenoids are class of natural products consisting of compounds isolated from different natural resources such as plants and animals. These are known as secondary metabolites. They can be obtained either by the enzymatic reaction of primary metabolites, or either when isopropyl isopentyl pyrophosphate IPP and dimethyl allyl pyrophosphate DMAPP condenses and produce a generyl pyrophosphate GBP, which is precursor to all terpenes. Now let's go towards the classification. Classification on the basis of their isoprene units. We will discuss. On the basis of isoprene units, terpenes are classified into different classes. Like monoterpenoids have 2 isoprene units having 10 carbon atoms. Sesquiterpenes have 3 isoprene units and 15 carbon atoms. In the same way, diterpenes having 20 carbon atom but 4 isoprene units. Sister terpenoids having 5 isoprene units and 25 carbon atoms. In the same way, triterpenoids having 30 carbon atoms but their isoprene units are 6, and because isoprene units are of 5 carbon atom. Now let's go towards a diagrammatic classification. The different isoprene units are attached over here, and a class of terpene is shown. How the different isoprene units are joined together to form a terpene. This tells us about isoprene rules. Isoprene rule was first given by Wallich in 1887. This rule states that when any terpenes or terpenoids thermally decompose, they give us isoprene units. In this isoprene unit, we can learn that how these isoprene units are combined to give us terpene or terpenoids. This tells us that each isoprene unit having 5 carbon atoms and the head of the one isoprene unit and the tail of the other isoprene unit join together and form a terpene or terpenoid. Here, sesquiterpenes found in the waxy coating on the apple skin is shown. The three isoprene units, tail by head, are joined and a complete structure of sesquiterpene is obtained. In the same way, another Carnot structure by head to tail combination is shown over here. Now let's go towards our basic topic, which is triterpenes. What are triterpenes? Triterpenes is a class of terpenes. Um, it is a secondary metabolites having 30 carbon atoms, 6 isoprene units. Triterpenes have many methyl groups which can be oxidized into alcohol, aldehyde, and carboxylic acid, which make it complex and differentiate it biologically. Triterpenes have many active sites for glycosylation, which convert into another big class of compound, namely saponins. When we starts a reaction of glycosylation on the triterpenes, they give us a big compound which is known as saponins. Saponins means a compound having characteristics of soap like material. Triterpenes is also a precursor to all steroids. Now let's go towards a classification of the triterpenes. A class or a compound of triterpenes is squalene having 30 carbon atoms. This diagram shows that the 30 carbon atoms, 50 hydrogen atoms by single and double bond. This squalene is also joined together by head to tail rule, but here in the center of this structure the isoprene rule is violated because there is a tail to tail combination, not head to tail at the end of the molecules, and at the starting there is a tail and head combination, but in the center there is a tail combination. Squalene. What is squalene? Squalene is a linear triterpenoid. It is an organic compound. Triterpene is colorless yellow color solution, soluble in organic solvent but insoluble in water. Originally, it is obtained from shark liver oil. Squalene is a biochemical intermediate for plants and animals. Because all the plants and animals can produce the terpenes, and it is biochemical intermediate compound for all plants and animals. It is precursor for the synthesis of the secondary metabolites like steroids, hormones, and vitamins. Many microorganisms uses squalene for a carbon source in their aerobic and anaerobic fermentation. Squalene was first discovered by Sugimoto Mitsumaru in 1916. He is a Japanese researcher described this compound as a highly unsaturated molecule. He assigned his name by a species Squalus, which is uh, the genus of the sharks. Many sharks belong to the species Squalus. That's why we named this compound as Squalus by their genus. The main source of squalene was a liver of marine animals. Because liver of the marine animals is rich in the lipid compounds. Squalene is a hydrocarbon chain formed by 6 isoprene units as we have discussed below. When the units are assembled, they form a triterpenes that gives us a lipid character. 6 carbon double bonds allow the molecules to be one of the most unsaturated lipids, and it is sensitive to oxidation. As I show you the diagram of the squalene in which the 6 carbon-carbon double bonds were present. Due to that carbon-carbon double bond, the unsaturation is present, and this shows us a lipid character which is sensitive to oxidation. but squalene is less and not susceptible to peroxidation because it has an antioxidant property. Now let's go towards the types of triterpenes. There are three classes of the triterpenes: tricyclic triterpenoids, tetracyclic triterpenoids, pentacyclic triterpenoids. The tricyclic having an example or having a group or molecule ambrine, which is isolated from ambergris secretion of the sperm hole. The tetracyclic compounds lanosterol and U-fol are basically the steroid carbon skeleton. All the steroids are made from the lanosterol means from tetracyclic class of triterpenoids of terpenes. Pentacyclic triterpenoids, oleanine and uracil, shows the uric acid and oleano acid, which which is a phytochemical active substances used in the plants. The tricyclic triterpenoids example of a molecule which is ambrane is shown. Now the tetracyclic triterpenoids U-fol, which is a precursor to all steroid, it is its structure. The pentacyclic triterpenoids alpha amyrine and beta amyrine. Alpha amyrine and beta amyrine are the precursor of uracilic acid, while beta amyrine is a precursor to oleano acid, which can be used by plants for their different purposes, and it is found on the surface wax of tomato, which is a fruit. Now let's go towards the uses and importance of the triterpenes and terpenes combinedly. Triterpenes can be used as antioxidant. Terpenes can be used as perfumes like rosemary, lavender. It can be used as spices because the terpenes can be found in the peel of the apple, lemon, pear. It can be used to make rubber, balloons, and gloves. It can be used as anti-cancer, antifungal, antiviral. The shark liver oil is used to boost immune system along with usual cancer drug to treat leukemia, which is a blood cancer, and radiation illness due to the cancer X-ray therapy, because it is the strongest technique of X-ray therapy for cancer, which is very illness and which cause many pain. That's in that situation um, shark liver oil capsules and tablets can be given to the patients. It helps in wound healing. It helps to prevention of diabetic complication. Some diabetic complications, diabetic patients can use these terpenes in different ways, in the form of tablets, in the form of prescribed medicines. Terpenes can be used as a folk medicines in for the different purposes. Now let's go towards the key points. Terpenes, as we discussed, produced by all plants and animals, precursor to all secondary metabolites such as steroids, vitamins, and cholesterols. Terpenoids are modified terpenes with different functional groups like aldehyde, ketone, or ether. Their types, mono, di, tri, tetra, and polyterpenes, are classified on the basis of their isoprene units: acyclic, monocyclic, bicyclic, tetracyclic, tricyclic, pentacyclic are classified on the basis of their ring structures. Terpenes are the precursor. Different precursors are used to make terpenes and terpenoids. What are that? These are isopentyl pyrophosphate IPP and DMAPP condenses to produce geranyl pyrophosphate GPP, which is precursor to terpenes and terpenoids. All the terpenes in plants and animals are produced by these condensation of IPP DMAPP. Triterpenoids, squalene, are obtained from liver oil of shark, helps to reduce body weakness. Tetracyclic triterpenoids, lanosteroid precursor to all steroids. Pentacyclic triterpenoids, alpha and beta amyrin, precursor to urusolic and alleino acid, and are biologically active phytochemical substances. Urusolic acid and oleano acid used by plants to produce different other uh, structures or compounds for their different purposes. On glycosylation, triterpenes produce saponin, soap-like material. Some terpenes give us a lipid properties. Triterpenes exhibits anti-inflammatory, antihypertensive, antioxidant properties. Triterpenes are optically active. Now, these all are about for the terpenes, triterpenes, and their structures, classifications, types, uses, and importance. Now, thank you so much for listening me.